Hello, we will be talking about regression analysis, and as you can see, this is the data that I am having. On this data, I have shown you how to apply reliability and factor analysis. Now the third test is regression analysis. For regression analysis, I need the total of one construct. Like, these are the questions which I have asked. This is score of all the questions. For reliability and for factor analysis, I needed these scores, but for regression, I'll find out the total of each questionnaire, each construct. So this is total of efficacy, this is total of turnover intention, this is total of motivation. So first, what I have done, I have copied these totals on different sheet, and from this sheet I will copy the data to SPSS sheet. So to copy data, it is just the same command that I use in Microsoft Office. It is Control C or Control C I have done. Now I'll move to this SPSS sheet, right click and then paste. So these are the three variables, total of 3 variables. I'm just renaming all these variables. For example, I'm naming this efficacy. The next is intention, and third is motivation. So I have named these 3 variables. Now the name of these 3 variables is appearing in the top row. I am going to find out linear regression. So for this, I'll go on regression, linear. If I'm having 2 variables, then what will I do? It is very simple. Dependent and independent variable I have to identify, and that already I have identified in my study. So I'm taking intention, turnover intention as dependent. I just selected turnover intention and shifted it to dependent window with the use of this arrow. Then efficacy as independent variable. I'm having 2 independent variable, that is efficacy and motivation. So I am transferring both these 2 variables in independent window, and in dependent window I have transferred intention. Other statistics and plot, I am not doing it right now. I can go for Durbin Watson, continue. Plots, I am not going to make any plot, save, whatever it is. I'm just leaving all these options and just click on OK. After that, you'll get the results on output sheet. Now, how to interpret these results? Here it is showing clearly that dependent variable is intention and variables which are entered are motivation and efficacy. This is method to apply simple linear regression, or you can say multiple linear regression, where 2 independent variables are used to find out their impact on one dependent variable. Regression analysis is generally used to find out the cause and effect relationship between variables. Variable is one is dependent variable, the other are independent variable. Here we have used one dependent variable and 2 independent variable. Number of independent variable can be more than 1, 2, 3, it can be any, but dependent variable will be only 1. So I am using the method enter. In this, I have entered all the variable at a time. I am not using any other method. I am simply using enter method for regression. And now I have to interpret this model summary. This particular model summary, 3 values you can see are R square and adjusted R square. When you are having one single variable as independent variable, we will be using R square value. When we have more than one independent variable, we will use this adjusted R square value to interpret the things. So this R is correlation coefficient. It is 0.715. That means the variables are correlated with each other. And as I said, we are having two independent variables, so we will be using this adjusted R square value. Adjusted R square value, what does this show? The variance in dependent variable due to these independent variable. So this adjusted R square value is 0.501. We will multiply this value with 100 to show how much variance it is causing. The value which I'll get after multiplying with 100 is 50.1. This shows that the two independent variables are defining 50.1% of variance in dependent variable. Whatever variance is in dependent variable is 50.1% due to these two dependent variables. Value of Durbin-Watson can be anywhere between 1 to 3. It is considered as suitable. Next, in ANOVA table, the most important thing that I have to look for is significant value. Whatever the value of f should be significant. That shows the model fit. The value of f, if it is significant, that shows the model fit. The model that we are trying to check is a good fit. Then we will move forward to this coefficient table. Coefficient table to interpret whether the variables are having significant relationship or not, we will look at beta value, t value and significance level. This constant will go in equation. Beta value and t value will show the relationship. So what these two variables are showing, the t value and beta value are significant at 0% significance level. That clearly says that there is significant relationship between efficacy and intention and motivation and intention. Okay, significant positive relationship, because this beta is not having any negative sign is not there. That shows the positive relationship and that this relationship is significant, and significant relationship we have identified from this significant level. The two values are significant. That shows that our null hypothesis, generally null hypothesis we take as there is no relationship between independent and dependent variable. For this particular study, where I have named these two variables as efficacy and motivation, and third is intention. So what will be my null hypothesis in this case? There is no relationship or no significant relationship between efficacy and intention. There is no significant relationship between motivation and intention, and from this significant value I can say that my null hypothesis is rejected, which means there is significant positive relationship between efficacy and intention and motivation and intention. This is what we are required to interpret from regression analysis. R value, R square value if we have one independent variable. Adjusted R square value is to be interpreted when we have two independent variable. Then F value, significant level, and then significant level beta t and these unstandardized coefficients. Okay, so this is all how we interpret regression analysis.